Hello and welcome to our Python tutorial series. To start off, we're going to show you how to install Python. So it's pretty simple. So you're just going to head on over to your web browser and we're going to search for, we're just going to search for download Python. Click the first link, download Python at python.org. So the version we're going to be using in this tutorial is 3.52. You can download it from this when you click this button right here. So you just click that and it automatically gives you a file. You save that. Just wait for the download. So just gotta wait for that. So we're just going to be using 3.5 because you'll notice throughout the series we'll discuss some differences between version 3.52 and the version 2.7, but they're pretty similar, just some minor differences, some arguably pointless differences, but whatever. So we're just gonna wait for this download. It's taking a long time for some reason, I don't know, but anyway, just waiting. Okay, there we go. So we're going to run this file. We're just going to install now. Say yes to all the dialogues. We're just doing express installation. We don't need to tweak with anything. And while that's installing, we're going to just close the browser. We don't need that anymore. So we're just going to wait for this to install. It's pretty simple. You just have to install like any normal executable file in Windows. And we're going to be after this installs, I'm going to just actually show you something else we're going to need for later when building Python scripts through both the console and in our IDE, which we'll be talking about in the next video. So this is about finished up. There we go. Okay, so now we have Python installed. So when we search for in the start menu py, we have Python. So what we're going to need to add an environmental variable to Windows for Python itself, so we can actually run Python through the Windows command prompt and use it later in our IDE. So first we're going to find the location of Python. So it gives you a shortcut. You're just going to go once again to open file location, and here we have this directory. So we're going to just keep this like this, to set this aside for later. And what we're going to do now, we're going to open the start menu and we're going to search for envi. So if you don't have it automatically for some reason, you can just you just find this PC, the longer way. So you find this PC, you're going to right click and you go to properties and you're going to go to advanced system settings, and here we can close this now. We're going to see environmental variables, so that's what we're looking for. Okay, so down below here you can see you're going to click this edit, not the one above, the one below. Well, actually we're going to look for one called path, and then we're going to click edit. Path is capital P and lowercase ath. So here we go. Here are some environmental variables from path, and we're going to add a new one. We're going to create a new one. So we're going to click new, and then we're going to copy this directory. So we're going to copy that. And okay, so new, copy, and that's it. And in case for safe measure, sometimes I'm not sure myself, but I like to add the actual executable files. So we can do the following. Hold on, let me just find let me just take this, and we're just going to say slash, and I'm casting up on the keyboard, so slash python.exe. And I believe, yeah, that checks out. So, okay. So just in case we need something. So now everything's set up and ready to go for Python, using Python. And in the next tutorial, we'll actually be showing how to set up our customized IDE, which I hope you tune into. So that pretty much concludes this tutorial. We hope you enjoy this series. Hello everyone. Before we move on to programming further in Python, we are going to set up our IDE. Now, I like to use Sublime Text. So we're going to open up our web browser and search for Sublime Text to download. So Sublime Text. I'm running on a 64-bit machine, so I use 64-bit. If you're running a 32-bit, just install 32-bit version. So it's downloaded, we're going to download it, and we're going to install it. And you'll notice later that we'll have to manually implement the Python interpreter so we can actually run Python files in Sublime Text. So we're going to install it. All right, close that. It's all finished. Now let's find our Python interpreter path. So when you search for Python in the Start menu, open File Location, and now for convenience sake, we're going to rename the Python file, the executable file that is, to Python with lowercases. So in my case, it's already done, but if it's different, right-click, rename, and type in Python, all lowercase. Moving on, let's open, oops, I actually accidentally closed it, so Python, and then you go to Open File Location, and then on the shortcut, you see from that search, you do go to Properties, and there should be a target field. You're going to want to copy this for later. You're going to save that for later. We'll show you what to do. Just save this for later. So let's open Notepad. So we have this on the side. Just keep a Notepad window open. Just save this path for later. And remember, this is arbitrary. So it could be different on your machine depending on where you installed Python. But on my machine, this is what it is. If you can't see it right now, don't worry. We'll zoom in later. So we're going to minus that. All right, so we have the target. Now let's open Sublime Text. So Sublime. All right, here's Sublime Text. Pretty simple, right? But first, before diving into things, we're going to have to set up the build system, that is. So here it says Python already, but this doesn't work because we tested it and there were some issues with the path. So we're going to manually make a new build system. So you're going to go to Tools, Build System, and then on the bottom you have New Build System like I just did. All right, so here's our new build. It's empty right now. So what we're going to do, we're going to open this. I have this piece of code, this piece of text saved. And you're going to want to copy this exact text, and I'll explain what it is in a sec. So we're going to copy this and paste it into here. And you'll see where our path comes into play. I already have it pasted in here for the sake of time. So you're going to have to paste the path from this file we opened in Notepad. Remember the file we opened in Notepad, we're going to open that and copy it to here. This is the path. And you have to remember that we're in Windows. So we have to use backslashes, and we're using double backslashes because they're escape characters. So be sure to use those double slashes in the path portion of this piece of text for the build. So when we're done, we have this copy pasted and everything, all the path is set. We're going to save this, and then we're going to save it as Python with a capital P, Python dot sublime dash build. So what this is, we created our own build system. We're going to save. All right, now we have Sublime Build. So let's make a Python file. So what we're going to do, we're going to make a new file. We're going to first save as. You don't have to do it like this, but this is how I do it. Save as. And we're going to name it test.py. That's a Python file extension. Oh, and of course, don't forget, if you're automatically inside a folder, go to the desktop for simplicity's sake. So save it as test.py. All right, so here's our Python file. And don't forget to apply the build system itself. So system, as you can see, we added another Python build system. The first one, as I said before, does not work. So here's the build second one. Choose the second one. Alright, so now we should have color coding for functions and stuff. So let's do welcome. So here's our line of code, print in Python. And in order to run this, we're going to do Control B, which is build. And as you can see, welcome printed in the console. And so now we have a full working Python IDE with Sublime Text. That is all for this tutorial. Please tune in next time. Hello everyone. Today we're going to make our very first Python program. To do this, we're going to simply use print. What print does is print a string to the screen. Now inside the parentheses we pass whatever string or other variables or arguments that we want to print out. As you can see, after writing that statement and pressing enter, it displays welcome to the screen. Now, in older versions of Python, in version 2.7 of Python, the syntax is a little different. This is written like this. Print, no parentheses, welcome. I can't type today, sorry about that. I'll get better, I promise. So as you can see, we wrote with the old syntax, but it didn't work in the new version, as it says missing parentheses in call to print. So that concludes this tutorial. We successfully made our first program where it prints welcome to the screen. I hope you'll join us next time where we'll be talking about data types. Welcome back everyone. Now we're going to talk about data types. In order to help us illustrate what data types we have, we're going to use the function type. Type. What this function does, it tells the interpreter to output the type of whatever's in the parentheses. So let's start with type 2. What this is an integer. An integer is any number, whole number, no decimal points. Let's do type now with 2.2. This is a floating point number. As you can see, there is a decimal point and numbers coming after the decimal point. Let's do a really long integer now. 2 with lots of zeros. In version 2.7, this would be a long integer. However, in version 3.5, this is a regular integer. Let's move on to type of true. If you're familiar with this, this is a Boolean. Boolean is basically true or false, 1 or 0. Now, a specific thing in Python we have is how we deal with characters. My bad. So, let's see here. A single character is interpreted as a string. That's because in Python, single characters are considered single-lettered strings. And we'll see the same type come out when we do ABC. It is also a string. So that concludes what data types we're going to be dealing with in Python. Next time we'll be doing variables. Let's talk about variables. If you're not familiar with variables themselves, that's okay. We're here to talk about them. So a variable is basically a reserved memory location with some value in it. So let's write our first variable, number equals 2. Alright, so if you've noticed in our previous tutorials, values we've used before are basically gone once they're used. But in the case of number right here, 2 can be reused over and over again. So let's make some more numbers. Variables, my bad. Real word equals, let's say a word. Okay, now let's see how these can be reused. So let's say a word. Oh, we see word. So let's do type of word. And we get class string. So basically we reuse word again and again. Moving on, let's try assigning one value to multiple variables. So let's say A equals B equals C. Now this is pretty logical, as in like in mathematics. You just have multiple variables and you assign one value. So let's demonstrate and see if this works. Print A 1.5, print B 1.5, and print C 1.5. As you can see, this worked. So let's talk about the comma operator now. What this does basically it can take multiple variables and assign multiple respective values to them. So let's have 1, 2, 3. Those are our 3 variables. And we have 1 as in the number, 2 as in the string, the word, and 3.0 as in 3 in the floating point form. Alright, so now we have our variables, and now let's see if this worked. So let's do print 1, we get 1, and print 2, we get 2, and print 3, we should get 3.0. Alright, so now let's demonstrate the dynamic nature of variables in Python. So let's reassign number as 1. And then let's make a string called str, and inside it string. And then let's say number again, but this time equals string. And if you've noticed, and if you're familiar with other programming languages, this might kind of look weird to you, but in Python, this is kind of unique. It's unique to Python. So basically, you could dynamically assign variables. You don't have to basically first define the type and the variable name to initialize it. In Python, you can just write a string variable name and its value. You don't have to worry about initializing it. And that's what makes Python pretty dynamic. And it's also important to note that variable names should be pretty descriptive, self-descriptive that is. So be sure to name, for example, string. If it's going to be a string, be sure it's pretty logical so you won't get confused later. Like, don't name string if it's a number and number if it's a string. Just be sure that you make variable names that are pretty logical and easy to understand. So moving on, let's see what things we can't give as names in variables. So first we're going to do import keyword and keyword dot kw list. So these are keywords. Basically, they are specific words reserved in Python for specific purposes and functions, like as we saw with print and type. So don't give any names to your variables that are in this list. And that is all for this tutorial on variables. Alright, before moving on and digging deeper into programming in Python, let's talk about the importance of indentation. If you're familiar with other programming languages, blocks of code are separated, for example, in C++ and C with curly braces. And PL and SQL and Pascal use begin and end. Now in Python, we use indentation. So we basically press the tab key to have a blank empty white space in front of pseudocode here, as we can see. So here we have two functions. We'll talk about functions later, don't worry, in our later tutorial, with pseudocode statements. As you can see here, the indentation separates the blocks of code. As you can see, the statements 1 to 3 are one block, and statements 4 to 5 are another block. So, as you can see, this code is a lot more readable and aesthetically pleasing, unlike before or in other cases where we had jumbled code just all over the place. This is actually, it helps us read it better and it's more organized. And that is all for this tutorial. We'll see you next time. Hello everyone. In this tutorial, we're going to learn how to clear the screen in Python. So first we're going to type out import OS, press enter, clear equals lambda colon OS dot system in parentheses single quotes CLS close parentheses, press enter, and when we use clear every time now, it'll clear the screen. Now, if you're wondering where I got this from, I just looked on the net for clearing the screen in Python. It's pretty simple, and that is all for this tutorial. Hey everyone! Now we're going to talk about comments. So, if you're familiar with comments, what they are, basically, they help us organize our code and tell other programmers what our code does. So, in Python, comments are notated with the hashtag symbol, or if any of you are older generation, the pound key. So when you write this, the hashtag symbol or the pound key, as I might say sometimes, anything afterwards is a comment. So this is a comment. As you can see in Sublime Text, it's notated with different colors. So you'll know this is a comment if it's a different color than this. Anyway, so anything after the hashtag is a comment. And this is actually an inline comment. So anything after the hashtag on the same line as that hashtag is going to be a comment. So if we wrote something afterwards, like just random text, see, as you can see, when I write the letters, it's white again. So that's not a comment. But when I add another hashtag, it's going to be comment. And then again, let's do it again. As you can see, comment. And if we run this code, let's do Control B. We're building in Sublime Text. As you can see, we are now working with comments. And the hashtags, anything behind the hashtags are not seen at all. They're not interpreted by Python. So let's erase those. All right. So to recap, they're one line only, and they're written as a hashtag, and anything after the hashtag is a comment. Now, this won't work in the middle of a string, so let's see that. As you can see, it's in the middle of a string and it's not a different color or anything. Let's build that. As you can see, the hashtag is included in this string. So remember, the hashtag must be kept outside of quotations in order to be a comment. And they're inline, so they only work with line per line. And that's it. That's all for this tutorial. See you next time. Hello everyone. Now segueing from the last tutorial with inline comments, some of you may ask, where are the multiple line comments, multi-line comments? Well, in Python, they're written like this. So we're going to use 3 quotation marks. So that's the quotation key, double quote key without the shift. So basically apostrophes, 3 apostrophes. So here you go. So this opens the multi-line comment. And we close it with another 3 quotation marks. As you can see, inside is a bunch of comments. So this opens them, and 3 quotation marks closes them. This is comparable to the /* use characters in other programming languages if you're familiar. So this would open and this would close. This is kind of the same, it has the same functionality. Alright, so this can be used to maybe block out a piece of code that you don't, a large piece of code that is, that you don't want to be compiled or interpreted, interpreted in Python, or you want to just write a long string of code of comments. So as you can see, anything comments, let's write some text. Alright, so as you can see, there are multiple lines. You don't need multiple hashtags like the last time. It's just everything between this is just comments. So let's build this. And as you can see, the comments are not interpreted. So that concludes this tutorial. We hope to see you next time. Okay, let's continue. So in this chapter, we're going to talk about manipulating numbers in Python. What this means is basically we'll be demonstrating basic mathematical operations, characteristics of dividing numbers, and then we'll talk about advanced arithmetic and operator precedence. But we'll also be talking about manipulation of binary numbers later on. So let's start with basic arithmetic. So we're talking about addition, subtraction, multiplication, and division, which are all simple and intuitive. And the syntax is pretty much similar to other programming languages. So let's start with addition. We're going to do print in order to see our results on the screen. So print 2 plus 5, for example. So this result will be an integer because both operands are an integer. But if we add, for example, 2.2, we'll get 7.2 from this, as you can see. So if there's even one floating point number in the operation, then the result will be a floating point. See, I added 2.0 here. The result now will be 7.0. Moving on to subtraction. So subtraction, is going to have a similar thing, similar event going down. So let's do 10 minus 5. And we're going to build that, it's 5. And if we had 10.0 to instead of 10, we're going to write 10.0 minus 5, that is, we're going to build and we're going to get 5.0. Moving on to multiplication. This is the same case with multiplication. So let's do 40 times 30. We're going to get 1200. And if we do this times 0.5, we're going to get 600.0 because 0.5 is a floating point number. So let's talk about now a interesting specific thing to Python. That is called the exponent operator, which is basically written as 2 stars. So let's write something out. So we're going to write 2 star star 5. This is basically 2 to the power of 5, which is 32. And so in Python, you can't write this with the caret symbol. This won't work. Instead, you should be using, this is actually a binary operator, which we'll see later on. This is using binary logic, which we'll see later on. But what this is called in programming languages is a binary operator because it has 2 symbols in it, so star star. So as you can see, we will get 32. Alright, and that concludes the tutorial on basic arithmetic. We hope to see you next time in our next tutorial. Moving on, let's talk about division characteristics. So, if many of you were wondering from the last tutorial, we didn't talk about division. Well, now we're going to talk about it. So, we're going to write an example. Division is written with the slash key, print, let's do 2 divided by 5, 2 divided by 4, for example. Right, that's division. But as you can see here, we're dealing with integers. And if we build this, we'll get 0.5. So in this version of Python, it automatically interprets it as 0.5. But if we do something like this, for example, let's do 23, hold on a sec, 23 divided by 5. We get 4.6. So in other older versions of Python, we will see that this won't return 4.6, rather it will return 4. But in this version, we're dealing with it automatically does it for us. So this is division. Now, so in this case, we don't have to do, in order to get the floating point, we don't have to add a floating point number anymore. So we got the same result. So in this version of Python, it does it automatically. Moving on, let's talk about another binary operator with 2 slashes. What this is, it is the floor division operator. What this does means the result of this division will always be rounded down. You'll get the floor value. So let's build this. As you can see, we got 4. So we forced the values to be rounded down. So even if we do a floating point number, we will get 4 instead of when we do with a single slash, we'll get 4.6. Moving on, let's talk about the modulo operator. What this is you divide and you get the remainder of the division. So let's give an example. Let's do 5 modulo 4. What this will do, it'll give us 1 because 4 goes into 25 6 times, which is 24. 25 minus 24 equals 1. So we get the answer 1. And modulo, the real number, having floating point numbers and everything applies here too. So if we did 25 for modulo 4, we'll get 1.0. We'll get the result as a floating point number. Moving on, let's talk about variables again. So in one of our previous tutorials, on variables, we can actually save our results of mathematical operations. So let's have variable A equals 2 plus 5. Let's have variable B equals 3.3 times 3. let's have c equal 10.0 divided by 25. Alright, so we have our saved variables. So let's print these out. So we're in our IDE now, so we can write multiple lines of code. And remember, Python does not use semicolons, it works by line. So let's have print, let's do A, and let's do build, and we get 7, which is 2.5. So the result of the mathematical operation was saved to the variable. And let's do the same for B. So we do print B, we get this result floating with the floating point number. And let's do C, and we get 0.4. So that concludes our tutorial. We'll hope to see you next time. Let's talk about operator precedence. So in Python, this kind of works similar to PEMDAS in real mathematics. So the hierarchy goes, the order of precedence, the priority goes parentheses, exponent, multiplication, division, modulo, addition, and subtraction. So let's demonstrate how some of these work. Well, just so you know, in a later tutorial we'll be talking about parentheses later on in more complex arithmetic. So let's do some mathematical equations. So this following mathematical equation, let's do print in parentheses. Let's do 25 times 15 plus 33 divided by 2.0. This is the same as having A equals 25 times 15, B equals 33 divided by 2.0, and then adding the two together. As you can see, the precedence is 25 times 15, 33 divided by 2.0, and then you add them. So this is basically a simple demonstration of some of the precedence in Python. So let's build that. As you can see, what it did, 25 times 15, 33 divided by 2.0, and we yielded a real number. And then we're also going to demonstrate how this precedence is demonstrated in A equals this expression, B equals that expression, and A plus B. So let's do that, A plus B. We're going to remove this line and then build. As you can see, we have the same result twice. So this is basically the same precedence demonstration as this line of mathematics here. And that concludes this tutorial. So now let's talk about complex arithmetic. This will be done with basically the parentheses. So let's take the example from last time. But this time we're going to add parentheses around a certain part. So we're going to have 25 times 15 plus 33 all divided by 2.0. That's what that means basically. So what this is the same as, this isn't the same as the previous in the previous tutorial's example. What this is basically, so we're going to set A equal to 25 times 15 plus 33. So what you can see here is with parentheses, we take even higher precedence. So everything inside the parentheses is taken as one result while still abiding by precedence rules. So this becomes one result, and then this is another result. So everything inside the parentheses is calculated first, and then everything on the outside is calculated then. So this is the same. Let's write this out. We'll demonstrate this. We'll demonstrate that this is not the same as in the previous tutorial. So we're gonna print that, and then we're gonna print A divided by B. And we're gonna build. As you can see, we don't have the same result as last time. We have a different one. Alright, so now let's say we have something even more complex. Let me just write this out. So we're going to have 5.0 times, open more parentheses. As you can see, we're going to use a lot of parentheses now to show how complex things can get. Minus 2 in parentheses of course, divided by 4 plus 1, all divided by 2. Alright, so what we did here is that we are dividing everything with, we're actually doing operations with different kinds of mathematical formulas. So let's demonstrate this. Hold on, I'm missing a parenthesis somewhere. Just give me a sec. So that's a parentheses. So we do have one around, oh, we're missing an 8. Whoops, I forgot an 8. 8, there we go. And so now we have a bunch of parentheses here. As you can see, there are lots of parentheses. I keep repeating myself here. So parentheses inside parentheses are going to take priority despite the mathematical operations involved. So let's do this. I forgot a parentheses. Alright, so this parentheses bunch is going to be calculated, and this one is going to be calculated, and this result is then going to be calculated, and then this is going to be added to 8. And then this whole thing is going to be one result multiplied with 5, and then divided with 2. And then this whole result is going to be modulo 4. We'll write this out, don't worry. So we're going to do A equals 16 minus 2.0. Then we're going to do B equals 4 plus 1. And then we're going to have C, which equals A divided by B. And then we're going to have D equals 8. And then we're going to have E equals D plus C. And then we're going to have F, which is equal to E divided by 2. I'm kind of skipping here some things. I'm kind of mixing it up a little. But this is basically the precedence, how things go. What you could do for E instead is something like this. For example, 8, E is equal to 8 plus C. So an F is equal to E divided by 2. And G is going to be equal to 5.0 times F, my bad. And I made a mistake here. I forgot the equal sign. I forgot one here too. So C equals, not plus. Got my mistake. So G equals 5 times this whole thing. And then we have finally H, which is equal to G modulo 4. So as you can see, the precedence is as follows. So you take the very inner parentheses and you do the operations regardless of the ones of the operations outside. So let's print this out. So let's print the first one, the first line of code. Don't forget to close your parentheses and open the proper ones. And then we're gonna print, my bad, print H. As you can see, we got the same result. So these letters demonstrate the precedence with parentheses and complex arithmetic. And this concludes our tutorial. We hope to see you next time. Now let's talk about binary numbers manipulation. In this sort of manipulation, in this operation with binary numbers, we use bitwise operators, which we'll dive into right now. So let's type out the print statement like we always do to display our results. Print, and now our first bitwise operator is the left shift, which is written as less than less than. So the first number on the left is our number to be shifted. And the number on the right after the operator is the amount of places to shift. So this number in binary, let's say we have 5 bits, we have 1. It's going to be shifted to the left 3 times. So 1, 2, 3, which gives us 8 because this is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3, which is 8. And as you'll see on the screen below, you'll get 8. Moving on to the right shift operator. It's the same thing, just it works the same way, just it shifts to the right. So let's take two numbers. Our number in question is 32. Remember, this number is converted to binary. So we have 32 in binary shifted 5 places to the right. So we have 6 bits, let's say, and this is 32 with the 6-bit 1, 2, 3, 4, 5, 6, yep. And then we're going to shift it to the right. So what this result is going to give is 1, 2, 3, 4, 5. It's going to give 1, as you'll see in the build below. As you can see, we got 1. Moving on to our other bitwise operators, the logical ones, AND, OR, and XOR. First, let's talk about AND. AND, what it is, it takes two values, and if both are true, then the result is true. So basically, if you have only either 2 ones on either side, then you get 1, as you'll see here. So we have these two numbers. Oops, my bad. I changed the operand. So on both sides now, these are both two numbers in binary. So let's write them out in binary. We're not going to build this right now. We're just going to demonstrate how these numbers look like. So 1 with 9 zeros, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 1 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 0 with lots of 1s. The rest are 1s. 0 with 9 ones. So when we AND this, since none of these are 1, 1, we're just going to get 0. So you compare each one, each bit place. So 0, 1, 0, 1, and so on, 1, 0, all the way to the end. And you get the AND result, which will yield 0 because none of them are 1, 1. So none of these are 1, 1. They're all 1, 0, or 0, 0, or whatever. So as you'll see, the result is 0, which is just 10 zeros. Anyway, moving on. Let's talk about OR. OR is another logical operator where if one side is true, then the rest is all true. At least one side is true, that is. So let's take our number from before. We're going to take our number, but this time we're going to OR it. That's notated with this line. Is shift, on the American keyboards, is shift backslash. It's right under the backspace button usually. Now let's talk about OR operating with OR. So 1, 0 is 1. We have all 1 zeros, so that means we have 1 on every time. So our result will be 511, which is 511, which is basically all these places are going to be 1 now. So that's the result, ORed. Right? Okay, moving on. Let's talk about XOR. XOR is kind of different from AND and OR. It's notated with the caret. And let's actually change the numbers this time to demonstrate it a little better. So 60 XORed with 13. What that's going to give us, let's do that in binary first. So we have 0, 2 zeros, 4 ones, 2 zeros again. And then that's 60. This is 60. And then let's do 13, 4 zeros, 11, 2 ones, 0, 1. All right. So here's our numbers in binary. So XOR, what it does, the two sides must be different in order to yield 1 or true. And if they're not, they yield false, which is 0. All right. So 0, 0, which is 0, 0, 0, which is 0, 1, 0, which is 1, 1, 0, which is 1, 1, 1, they're both the same, so it's 0, 1, 1 again, 0, 0, 0, you get 0 again, and 0, 1, you get 1. And this number should be 49. We'll test it out right now. As you can see, we built it, and we got 49. So that concludes this tutorial on bitwise operators. We hope to see you next time. In this chapter, we'll talk about strings and how to manipulate them. We'll go over some basic formatting options, and in the end we'll demonstrate one useful method that works with strings. So we're going to start off with basic string manipulation. If you remember in the previous tutorials, we have demonstrated how to define strings and how to assign a string to a variable. It looked like this. So we're going to have a variable called string. Here we go. String, CCleaners. So close that. Okay, so string equals, and we use single quotes, I am a string in Python. Another way of defining a string is doing the following. So you can also use double quotes in Python. So in Python there is no difference here. So we're just going to copy this, and there we go. So build that, there's no problem. So they basically, oh, I should change the name of this. We're gonna call this string1. Okay, so with strings in Python, you can access a specific character in a string in the following way. So we're going to say string, and then we're going to use the square brackets after the name of the variable, which is a string, and then type in an index, which is an integer. This is called indexing. It starts from 0 and goes up to the length of the entire string minus 1. So to access a character, just specify the position, or this index right here, in the string. To get the length of the string, we use the function len. So we use the len function. For example, we're going to say the following. So len, my length is 15. So, and we can also pass a string variable to this function as follows. So instead of actually directly passing a string, we can just use this variable. So let's say string, this variable right here. Python also supports another way of indexing, which is not standard. For example, we have string in square brackets minus 1. The result of this character is n, which this is called inverse indexing, and it returns the last character of the string. So let's see, let's add on a 1, here we go. So let's actually print that out and see what happens. So print, remember our print function from before, and b, whoops, that's not, there we go, and we got n. And as you can see here, the last letter is n. So, for example, so by using this, if you wanted to get the second to last character, you would put minus 2 instead of minus 1. So, and then we got 1, and we got the O from Python right here. And you can do minus 3 and so on. So moving on, if you try to assign a character using indexing, you would get an error. For example, let's do the following. So let's say string index minus 1, so the last character is going to be, we want it to be equal to x. And let's build that. So what we get here is a type error. str object does not support item assignment. These types are called immutable types. Later on, we'll demonstrate how to assign a specific character if there is a need for it. So anyway, moving on. Another interesting thing about Python is the so-called string cutting. For example, we're going to have, so let's erase this. We can erase all this now. We're going to have string, we're going to have string in square brackets 5:11. This will return string, that is, it will return all characters that start with the 5th index and end with the 11th index. So let's do that. So it's going to return this right here, this part of the whole string. So if we print that out, we're just going to print this out. We get, oh, why is it a string? Oh, because I put a string. So if we say without the a, we'll get string. There we go. If we don't specify the value of the first index, it is considered that it starts from the beginning and then just goes to the second index and goes to the end of this index. So let's do that right now. So let's do blank colon 5. And then we get IM, so we get everything up to the 5th index. That includes the space. So, and if we do this for, let's say 15 at the beginning, and the other side is blank. So we're going to get Python. So we start at the 15th index, my bad, and then go all the way to the end. So we have something called concatenation in strings. It's basically adding strings, putting strings together. And so we can do this, it's pretty simple in Python. So what we do, we're just going to say, so let's make a new variable called string2, and we're going to concatenate into this. So we're going to say, we're going to add these two separate strings together. So we're going to say con, and then we're going to use a plus operand in strings. This is concatenation, and we're going to say concatenation. All right. And then when we print that, keep in mind there's no space here. If you want to add a space through this operand, you have to do it manually. So you have to do con space, add a space, but anyway, you'll get the idea. So let's do statement. As you can see, it gets added together. We also have something called repetition, where you can actually repeat a string multiple times. So let's do it with this example now. We're going to use 2, then we're going to use a star operand with the string. What this does, it repeats this string right here this number of times. So it's going to repeat concatenation, actually, because it's kind of like operand, so it repeated con twice and then concatenation once. So there you go. You can use, pretty much like math operands, you can use these too. So this using a 2 star repeats the string after the star a certain number of times based on this number. Anyway, keep in mind that you cannot use this syntax when concatenating. Wait, no, sorry. So anyway, so I should move back to concatenation for a sec. So you can concatenate a string without this plus right here. But you have to keep in mind that you cannot use the syntax when concatenating a string variable. So if we did this, we get the same result, so we concatenated without the operand. But if we say have con, and we call this con, well, it should be 1n, and then we have, let's just call it cat, we're going to call it catenate. We cannot have them concatenated without an operand if we're doing it over the variable. So if we write con cat, you'll get an error. But if we do con plus cat, you'll get the proper result. So you have to use the plus sign when dealing with a variable. This also works. So you can, if you have anywhere you have a variable, you have to use the plus sign. So if you have a variable plus a string, like without a variable, so concatenate, this works. But without this plus, it won't work. All right, so now we'll demonstrate how to replace a character in the string. So let's start over. We can just leave that. Okay, so let's say declare a new variable called word, and then we're going to call it, we're going to say Ford. And then we're going to say word, so we're going to assign the value, the following value. So we're going to say L plus word from the first index all the way to the end, or index 1 all the way to the end. What we did here is create a new string which is concatenated version of the specified character and other unchanged characters. So what's going to happen is going to copy ORD, it's going to concatenate L with ORD. So we're going to print, and then we're going to say word. And there we get Lord. So those are the basic string manipulation techniques we have in Python, and that pretty much concludes this tutorial. So when working with strings, the format method is very useful. Here are some examples to demonstrate that. So we're going to use the print function to display these statements directly. So print, and we're going to, inside this print, we're going to see how this format method works. So let me type out the following example. So you may have seen this before in your programming, I don't know, life, career, whatever you call it. In a string, you might have encountered curly braces with a number inside it. So we're going to say, today I had curly brace 0, curly brace, cups of curly brace 1, curly brace of, yeah. So here the format, so what's going to happen here, after this string, we're going to type in dot format, this method right here. So inside this, we give certain parameters to be passed that will replace these right here. So this is something else is to be expected here. In this number, this is going to be replaced by 3, and this one's going to be replaced by coffee. So let's build that. So as you can see, instead of saying this, it says today I had 3 cups of coffee. So that's basically a simple way of how the format method works. You can also use this method to assign values to the parameters in the string. So instead of using like these index numbers, we can use actual variables. So let's say print, and then we're going to say, we're going to have a list of prices. So let's say list of prices, prices, colon, and we're going to open some parentheses. This is just a string, no need for parentheses really. So we're going to open curly braces for X, open curly braces and close them for Y, and likewise for Z. So we have 3 variables. And then in the format method, we're going to assign values to these variables. So X is going to be 2.0, Y is going to be 1.5, and then Z is going to be 5. And then when we build that, you'll get these variables replaced with actual numbers. Another thing you can do is have positional and keyword arguments together at once. So you can use this positional and this keyword arguments, these variables right here, or keywords as they're called. So let's do that with another example. So we're going to print, inside that we're going to say the following. So I didn't open quotes, open our curly braces, vehicle, had curly braces 0, crashes, in curly braces 1, months. So as you can see here, these keywords aren't sort of indexed with these positional arguments right here. So when we do that, we have to keep in mind that the 0th position must go first. So we have 5, which is going to go here. And we're going to have 6, which is going to go here. And then we're going to define vehicle. So vehicle is equal to car. And then when we build that, everything gets filled in as expected. Moving on, you can use this method to align the text in a certain manner. You can align it to the left or to the right. So the left assignment is going to be enabled with the following syntax. So we have in the string, we will keep this outside the string just for the syntax demonstration. So we have colon, some sort of character, and then we're going to have left. This is the left alignment, is the less than, and then for right alignment, we're going to have the greater than symbol, like that. So in this, when defining the alignment, we have to specify the character which will replace the empty spaces and the number of places that the string will occupy. If that number is smaller than the string length, then the string will be printed out without alignment. So let's do this. Oh, so we have this syntax, and then we have dot format. I forgot to mention this, my apologies. And in the format, we have the actual string. So first we define the alignment dot format, the actual string itself. So let's erase that and see how this actually works in action. So print, and then we're going to have in quotes, curly brace, colon, left alignment 20, and then so left alignment 20, and then we're going to have dot format, and then inside format we're going to just say example text, and you see it's left aligned. So let's see the same thing with right align now. Okay, right align. And as you can see, it got, oh, this is the left and that's right alignment. Okay, moving on. The format method is useful when formatting binary, hexadecimal, and octal numbers and so on. So we can see this in the following way. So let's see format, print actually, and then we're going to use a similar syntax as before, but this time we're going to say colon X, colon B, this is for binary, dot format, and what string we want to modify. Wait, no, that's inside the string, my bad. So we have that, dot format, and inside that we have 21, let's say, and we get an error. Oh, that's because I made it a string, my bad. Should be like that. There we go. When we get the binary form of that, sorry about that. And we have a similar syntax for hexadecimal, which is notated with X. So B is for binary format, X is for hexadecimal. And we get the hexadecimal form of this integer. And then for octal, we use an O instead. And then we get the octal form. So with that, that pretty much concludes this tutorial. To conclude this chapter on strings, we'll talk about some specific characters in strings such as quotations. For example, if you try to type something like this, so let's say we have in quotations, we have the contraction I'm, a string in Python. So as you can see from the highlighted syntax, we don't get the result we want. So in order to print single quotations like in a contraction like this, you need to put the entire string within double quotation marks. So that's the difference here between. So, and this will build without a problem. So if you're expecting a single quote like for apostrophe inside a string, you should use the double quotes. And if you want to use a quotation, for example, you want to say Python with quotes around it, you should use single quotes. So that's where really the key difference between single quotes and double quotes come in. So you should be aware of that. So let's change this to I am a. So then this quote works, builds without a problem, and you know how that looks like. So, but if we want to use both quotation types, then we would have to use the following. We have to use the backslash before the quotation. In case of the backslash sign creates problems, we can put the character R before the string, for example. Well, actually, let me just display the backslash first. So I backslash quote, as you can see it's highlighted here, M, a string in Python. And this builds without a problem. So this backslash actually is called escape. This is called escaping characters. So we use that backslash on the character we want to display that wouldn't otherwise be displayed in a string like this. So anyway, so in the case of the backslash sign, if you want to actually use that, it creates problems. So like I said, we put the R in the string, for example, print. So we're going to say R, C, colon, This is just an example. Number slash nan. And then we get the proper text from using this R. Also, if we wanted to find the output of a string ourselves, we can do so by putting the string inside triple quotations. So let's get rid of this. So we're going to say print, and we're going to say 3 quotes. So 3 quotes. We're going to have a backslash, backslash, and then we're going to have some let's say hello, colon, and we're going to say user defined look Python output, and then we'll press enter, and then we're going to build that, and then there you go. So with single quotes, with triple quotes like this, you can define the actual output of the string itself. So that pretty much concludes this chapter on strings. Thanks for watching. In this chapter, we will talk about loops in Python. To get a better understanding of how loops work, we will first go through conditional statements and logical operators. We will use these when creating complex conditional statements. And once we're done with that, we will be explaining and demonstrating 3 different ways of writing loops. In the end, we will learn about the ternary operator. Starting with logical operators and conditional statements, we have the following symbols that we use in conditional statements. Less than or equal to, less than, greater than, less than or equal to, I made a mistake before, pardon, so we have less than, greater than, less than or equal to, greater than or equal to, not equal to, and equal to. Now let's demonstrate some examples with these symbols, with these conditional conditions. So let's print out 5 is less than 6. This is going to return true. So with conditional statements, we have Boolean values. We have false or true, or 0. So we have false is 0, and true is 1, or any other number that is not 0. So as you can see, 5 less than 6 return true, which is a Boolean value. 10 greater than 11, which is false. Let's do 2 equal to 2, which is true. Then we have, moving on to greater than or equal to, let's say 2 is greater than or equal to 3, which is false. Let's do less than, 2 less than or equal to 3 is true. Then we have not equal to, so let's do 4 not equal to 2, or say 1 to change it up a little, which is true because 4 is not equal to 2, equal to 1. We can also use strings in this case. So let's say ABC equals ABC. As you can see, it returns true because these strings are of the same length and have the same number of characters. And keep in mind, we can also use variables in conditional statements. Moving on, let's talk about logical operators. We have the following: not, and or. And as you can see, I wrote them in operator precedence. So not has the highest priority, then and has the second highest priority, and or has the lowest priority. And let's illustrate now with some examples with these what we just said. This time we'll use variables. So let's say our variable A equals true, variable B equals false. And we're going to print not A. So this is not true. Literally not true. So A is true, so not A is true. let's do something with and now. So A and B, oops, I forgot A and B is false, because with AND logic, true and false yields false. And let's do something with false and false, which is false, and do true and true, which yields true. Now let's do OR. So true or true is true, true or false yields false in OR logic, and false or false yields false in OR logic. Moving on, we can talk about now using parentheses in order to make more complex statements. So we can change the order of precedence in a conditional statement. So let's start off by making some variables, declaring some variables, pardon. So let's say 5, D is 5, E equals 1, F equals false. We're having a couple mix right here, as you can see. F, G equals Python. H equals sum, like the word sum in a string. And to make our job easier, let's have another variable. Let's call it Z, which is going to have our complex statement inside it. Alright, so let's type it out. So we're going to start off, we're going to make something quite complex here, which we don't recommend. It's not recommended actually to write such complex statements, because you'll wind up getting confused in the end in your programs. So just if you're going to use complex statements, be sure you know what you're doing, because with the more complex the statement is, the more room there is for errors. Alright, so let's do this. So let's do E less than or equal to D inside this not statement. Then we have and we're going to have G greater than or equal to H. And then we're going to keep that closed. And then we have or F. As you can see, their variables are being used here. And on the other side, we have 1. So we have a large and operation going on here, with one side with 1, which, as we said before, is true, and it's always true. And on the other side, we have this big, complicated statement. So let's break this statement down. We're going to start, since we have parentheses, we have the order of operator precedence. So let's see. Let's start with this not statement right here. So we have not E less than or equal to D. This means, so not 1 less than or equal to 5. So this statement is true. And then we use not, which means we get false. So we're going to have false and whatever this is, which we're going to say right now. So D greater than or equal to H. So, sorry, G greater than or equal to H. G is a longer string than H. So we get true here. So we have false and true, which yields false. And then on the other side of this OR statement, we have F, which is false. So we have false or false, which yields false in this whole parentheses section. And then we not that, which we get true. So not false is true. And then we have this whole side is true. And then we have this 1, which, as I said before, keep repeating, is true. So we're going to print out our result, our variable. As you see, we get 1, which is true. And that concludes this section. We hope you tune in next time. Now let's talk about if statements. If statements are used together with conditions to determine which part of the code will be executed next if the evaluated condition is true. Think of this as a sort of conversation between two people. So let's make a variable called passerby speech, just like in a normal conversation. We're going to set this equal to hello. And now we're going to check this. Oops, I made a typo with a G, excuse me. Alright, so let's make our if statement. So we're going to start with writing if. Then we're going to write our variable. As you can see in Sublime Text, we have autofill, which is a miracle, kind of. It makes our life a lot easier when programming in Sublime Text, writing programs, excuse me. So if passerby speech equals hello, which it does, or we're going to, as you can see the or and a logical operator and our conditional operator used before, so we're using these in if statements. Alright, so hello is if passerby speech equals hello, or if passerby speech equals hi. As you can see, they're both two greetings. The result is going to be print hi, how are you? Alright, so basically this is illustrating a normal greeting. So if someone says hi to you, well, depending on who you are, you just say hi back and how are you? So let's build this. As you can see, there is a syntax error here, so let me just check my syntax. I believe it is the indentation. Oh, no. As you can see here, this is a common mistake sometimes with programmers. What they do, you have to make a double equal sign and not just a single one, because in if statements, this is actual condition. So be sure to memorize that. And this is in a declaration of a variable and setting it equal to a value. So just remember, in if statements and conditions, use the double equal sign. Alright, so let's build it. And there's a hi, which is something... Oh, in Python, we also have to add a colon in the if statement. I forgot to add that colon before. So let's build it now. As you can see, since passerby speech equals hello, which yields true in this if statement, we get hi, how are you? So anything within the if statement is processed when the result of this condition is true. Alright, moving on. So as you can see, let's just write our our if statement formula, sort of. So we have if, we have a condition, and then we have to indent. Remember, indentation in Python is very important. So anything indented... Oh, and of course, again, I forgot the colon. So we have condition, let's say statement, colon, and then anything after that indented is within that if statement when that condition is true. So we have some code here. Let's just write some comments, code, and we just have some pseudocode like print and so on. So this is just how our if statement works. So we write if, our condition, then a colon, and then after that we use indentation to sort of contain whatever to interpret whatever code is to be executed when we have the condition equal to true. So to recap, just remember that indentation in if statements, like in most of Python, is very important. So like this, let's write something. If, just some pseudocode, if true, colon, and we didn't indent, print test. This is not the right way to write an if statement, so we're going to need indentation here. And that is all for this tutorial. We hope you tune in next time.